I feel so alive, so cool, so fine, alright. You know this good, I have a good, good feeling. And I feel so alive, so cool, so fine, alright. You know this good, I have a good, good feeling. And I
Dun-dun-dun. I'm looking for someone that is a Minecraft server ops admin expert. If you happen to know anybody, let me know. Pretty quiet on the social medias this morning. Running my own Java server. Yeah, I started with Java, but I'm having some problems setting the min and max memory of the JRE. It's erroring on me, and I don't know what to do about it. So we're going to troubleshoot that tomorrow on the stream and get that set up, because it's not letting me set more than a gig for each. All right, let me switch this music around so we can listen to this here, guys. All right. And we'll turn that on. Uh-oh. Oh, I got to unmute this one.
So great to see so many of you up early here in Las Vegas. Welcome to the big show for the Deep Racer League 2019, and a welcome in as well to all of you.
This pulls on my geek heartstrings so much.
The world. Well, I'll tell you what,
Pro-Am was like one of my favorite
Deep
Nintendo
Racer
games.
League. It all culminates here with our
soapbox derby
championship
racing
round
and all
coming
kinds
up
of
in just
stuff
a few
too.
minutes, but it
this
has
is my
been a
jam right
remarkable journey to this point. It's been a global competition, without a doubt, this year. 17 countries, 21 cities, and 6 virtual competitions. That's what encapsulated the 2019 Deep Racer League. It's also been a season of tremendous progress. If you go back to a year ago when we unveiled Deep Racer and crowned our inaugural league champion on this stage, last year, Rick Fish was able to take home the cup with a time of around 51 seconds.
Wow.
Since that time, that lap record has been shattered. Indeed, our developers have been hard at work, and now the lap record on that very circuit has been lowered to somewhere around 7 seconds. It's amazing what we have done in just 12 months. Over the last 48 hours, our fastest 64 developers out of the tens of thousands who tried to make the field here in Las Vegas have been battling it out for the right and indeed the honor to be a part of the Championship 3 that will be taking to the stage in just a few short minutes.
This dude could call a NASCAR race. He's really good.
To our protagonists, let's take a quick look back on what's taken place over the last few days, the intense competition that has led to this moment.
Yes.
Ooh, look at that acceleration.
I have no idea how he's done that.
Watch the best of the best go at it for the title. Thousands of developers have been gunning for those 64 spots.
The moment of truth. It is now or never.
This one's going to be tough.
Fractions of a second between hero and zero. Last chance to dance here in Las Vegas. Well, the competition has been fierce, but only 3 could stand on the stage as the Championship 3. Our 3 finalists here in Las Vegas with the chance to race for the title of Deep Racer Champion in 2019. Now let's introduce you to them, starting first with our top qualifier, the champion at the Tokyo Summit, the world record holder on the previous generation track with a lap time of 7.44 seconds, and the fastest developer throughout the week so far here in Las Vegas, current record holder on this generation of racetrack with a time of just a shade over 8 seconds. She's been the fastest developer on 4 wheels all throughout the season. Please welcome to the stage, all the way from Japan, So-La! So-La races out of the powerful DNP stable, which has sent 2 finalists here to our Championship 3.
This is like esports on a whole other level.
Style has been thrilling to watch all throughout the action so far here in Las Vegas. That style has been illustrated by just a 35% lap completion ratio, and she has easily the most resets per lap of any of our Championship 3. Nevertheless, it has been a recipe for success. She is the world record holder.
Damn.
Our second competitor coming to this stage is her teammate, also from that powerful DNP team. Like his teammate Sola, he reaches the Championship 3 undefeated in head-to-head matches in the round of 16 yesterday. He was the runner-up to Sola in Tokyo, a champion on the virtual circuit. Please welcome to the stage, Fumiaki! In contrast to Sola, Fumiaki's fast and consistent style has been his calling card. He's defeated his opponents in the round of 16 by an average of 1 second. He's favored by our AWS analytics to come away with the cup with the probability of victory at 37%, and his 51% lap completion rate is the best of our Championship 3.
Wow.
And joining these two on this stage is our Taipei champion. He had to survive the last chance bracket to advance to the finals after a head-to-head loss to Sola in the round of 16 yesterday. He's a graduate student studying reinforcement learning at Chiaotong University in Taiwan. Ladies and gentlemen, I give you Roger Chu. Roger's best lap time of the event so far in Las Vegas, 9.064 seconds.
They're already doing drone
of our
racing.
Championship 3.
It's got to be AI drone
he has
racing
the
next.
fastest average lap time of any of our 3 competitors here, and in our slightly altered championship format, that could prove to be the difference. And it would not be a race event without a celebrity to wave the flag. You know him well, folks. Please welcome to the stage the one and only Matt Wood. Well, there they are, your Championship 3, our celebrity flag waver as well. Let's briefly run through the rules. How is this going to play out? And we'll get our championship matches started. Unlike League Play, which has seen each developer get 4 minutes of track time to set their fastest lap.
I thought they were going to bring out like Darryl Waltrip or something.
Boogity, boogity, boogity! 90-second attempt per competitor. That is it. One chance to dance, period. And at the end of each competitor's 90 seconds, we'll know the fastest lap. The fastest lap set amongst these 3 will be your 2019 League champion. Our track boss, you'll see him walking around in the track assisting our competitors. Tim Bruce, he will be here doing his best to give our competitors the most opportunities possible. It's an important job, and we thank him for it. All right, with that said, it is time to begin the competition.
Tell you more about the Minecraft server?
Ladies and gentlemen, please get ready because Sola, we need you to take your position. Sola, you will be on track.
So I'll turn this down a little bit while they're doing all the introductions and everything. So basically what we wanted to do was stand up a Minecraft server. Oh, they're actually going to run it now. Hang on. I'll talk about it in a second, Mars.
Tablet at hand.
1 second.
She'll have the control of the throttle there. All right, let's get our countdown to the green flag on. Here we go. 3, 2, 1. Sola, your 90 seconds has begun. So this is a different track layout here this year than we saw throughout the circuit this year. Also, it's a different layout than we saw at reInvent a year ago. It's much different here. That lap will not count. The car went 4 wheels over the white line. That's what our track boss is watching, as you saw right there. Now, this is costly for Sola because there's only 90 seconds to work with. Remember, we talked about her style. It's very aggressive. She tends to come out of the gate very fast and slowly dial back the intensity to find that hot spot. Here we go. That's the first official lap of the summit so far. 12.384 seconds. Looks like this lap will most likely not count. Coming around here, starting the next one. Still has that 12.384 to fall back on with just 35 seconds remaining. It's worth noting that just 90 seconds to work with. I think our developers are likely to be a bit more conservative, but how about that? Not much conservative about a 10.236. Just 20 seconds remaining for Sola. Can she improve? We're looking at it best, perhaps 2 laps. And it's critical to get a nice running start, if at all possible. But it looks like she's going to have to do it from a standing start. This will be the final lap. Matt, get that checkered flag ready. The clock has hit 0. She'll be allowed to complete this lap. Can she improve on 10.236? She cannot. Checkered flag waves. Sola's run is complete. Ladies and gentlemen, the fastest developer, the world record holder, Sola.
What did she get? 10.2.
10.236 will be the time to beat, and Fumiaki, her teammate and colleague from the DNP Publishing House, is up next.
Yeah, so I think that big thing that's on the front of the car
What
is
can
a
Fumiaki
combination
do
of a
in his
camera
allotted
and
90
there's
seconds? We're
at
about
least
to find out. Let's
4
get
or
the
6 different
countdown
little
on.
sensors.
Here we
you
go.
can see the camera
3,
on the front there.
2, 1. Fumiaki is on it into that left-handed bend at the start of the
that's not a
lap.
good start.
Now, we talked about his style as being a bit more conservative, a bit more cautious, but he's coming out of the gate with some aggression. We saw him in warm-up this morning looking very solid here on the track. That lap will count because of the reset. He did lose some time, 16.366, but at least there is a time registered. It is worth noting that the car is allowed to be reset twice on a lap and still have it count as an official lap, as we've seen here on Fumiaki's lap so far. A little bit better there on lap 2, 14.716. Interesting to note, though, that this horseshoe bend has been the bugaboo for Fumiaki so far. Halfway through the 90 seconds, and 12.756 is best. Look at that, just hugging that white line. Dancing dangerously, but a little bit faster. 11.654 for Fumiaki with 30 seconds remaining. What do you think about this, folks? Is it going to
that
be
was a
better?
good one.
It is, but it's not fast enough yet. 11 flat, 11.065, just 17 seconds, most likely 2 laps remaining. This lap will not count because the car exceeded track limits, but the track boss, Tim, allowing it to continue to give him a running start here. Has to slow down, has to get back to the line. It's not going to happen in
That wasn't
time,
that
or
good.
is it? Well, let's go ahead and let him go, but the car exceeded track limits again. Fumiaki's run is done. He'll have to settle for an 11.065, currently second of our 3 competitors. So it all comes down to our last chance qualifier, Roger, who had to race his way through the last chance bracket yesterday. The student from Taiwan has the tablet at hand. He's ready to go. 90 seconds on the clock. Let's get the countdown on. What do you think, folks? Can he do it? 3, 2, 1. And he's on it. Roger on his way. Let's cheer him on, folks. He's still gunning for the best lap we saw from Sola earlier. 10.2 and change. That's the lap he's going to need to beat if he's going to host the Deep Racer Cup. Here through the Flying S's now onto the front straightaway, into this Parabolica left-hand turn. Off track though there. Roger, again, we talked about it earlier. He was the slowest of the 3 qualifiers
2
to
challenges.
make it
Use
here.
ML
So
to keep
he's been
yourself on and use
reprogramming
real
his
racing
model
principle.
overnight.
Yeah.
He told us yesterday when he
I'm not really
qualified,
sure how this
I know
works,
the
'cause they're
model I've been
touching
using
something. It's like they're
cannot
controlling
compete with
something.
Sola, cannot compete with Fumiaki, so I've got to do something. I need to be aggressive, and that's what he's doing right now. Here we go, his first official lap, 12.156. That's something you can build on. Let's place the car back, and he's back on it here, but only 35 seconds left. Pressure packed here with just 90 seconds to work with. Around to complete another lap. Let's see, can he get through this opening sequence cleanly this time?
Go, go, go.
It's been tough. It's not looking promising, but there is still time. 20 seconds left. Sola right now holds the fastest lap. Can our double world record holder hold on? Just 12 seconds to go. What do you think, folks? Who's going to win?
Sola.
7 seconds to go. Tim hustling back to the start-finish line. One last flying lap for all the marbles for Roger. It's not going to happen. Time has expired. A valiant effort from Roger. 12.156, his best lap time. But with that, we now know our results. Let's make sure our timekeepers have been able to identify those times. They've been reviewing everything. Let's take a look. There it is on the screen.
Controls problem,
Sola,
yeah.
your champion, at a 10.236. Fumiaki in second, Roger in third. And with that, let's welcome our trophy winners up to the podium to collect their trophies, starting with third place, Roger Chu from Taiwan. Matt Wood here to shake his hand and congratulate him. Well done, Roger, coming out of the last chance bracket. A tremendous effort here in Las Vegas. Second place goes to Fumiaki. comes up just 0.8 of a second short of his teammate Sola. Well done. And how about it? Your champion for the year 2019. She's had the world record on the previous track. She's got the world record here, and now the Champions Cup as well. Ladies and gentlemen, a round of applause for Sola.
She would probably destroy you at RC Pro-Am on the Nintendo.
She wins an automatic berth in the 2020 Deep Racer Championship. She'll have tracks named after her. She'll have also the choice of a $25,000 scholarship for machine learning degree or 25,000 AWS credits. Congratulations to each and every one of you.
I'll take 25,000 in AWS credits.
Season of Deep Racer competition. We really have come a long way.
I'm going to turn this down a little bit, guys. He's really loud.
Even bigger things are planned.
Let's see. Last year, they gave those away if you were lucky enough to get in the session. What, are you talking about the cars? Like the whole car, they were giving one away? We had to build one of these in school many years ago. It's easy to do with Arduino and phototransistors. Huh. It's not something I've ever tinkered with. Oh, wow. What's this? Oh, the new cars. 2 cameras. Whoa! So I guess the current one doesn't have LiDAR, but it has the camera on the front. I think it's the new one, the 2020 one, that's gonna have dual cameras and LiDAR. You saw it spinning on the top.
Welcome to the AWS reInvent 2019 Keynote program.
Is this the Goldman Sachs
Please take your
CEO
seat.
again?
Our show will begin shortly.
All right, I'll turn that down a little bit so we can chat. Yeah, the car was the swag. Man. So everybody that got in the session got one of those cars? I think so. Once word got out, the wait lists were insane. That's one of those things where you don't tell anybody, and it's like, if you look under your chair, you'll find a golden ticket to redeem for a car or something like that. I always liked the, what was the one in Ready Player One? It's the classic joke where you do, if you look under your chair, you'll see that there's nothing there. I've been waiting for the right session to present to pull that on folks at some point. This is not the Goldman Sachs CEO. Apparently, he is a DJ and was DJing before the keynote on day one. Sean says they're using stereo vision and LiDAR to learn the track in real time. That's pretty badass. Yeah, it is. But don't you also have to write the... You would have to write the code to be able to process that in real time. I guess that's what the challenge is, right? So it's, how do you gain an advantage? Do you process it a different way? That would be the thing that I would be curious about the most. Don't go anywhere, guys. I'm going to hit the head real quick before the keynotes get started. We got about 10 minutes, so before Werner comes up, grab a drink, get comfy, and get a little snack, something like that, and we'll be right back for the keynote. It's pretty impressive that he's doing this without a set of monitors on, set of headphones on. I was trying to see if he had like in-ears in or something like that. You wonder if the advantage is which ML algorithm? Yeah. Is that the tactic? Are you writing your own? Are you using one that's open source out there? Are you bringing some other stuff in like that? Actually knowing how to race is going to come into play? Yeah. It's like, was it Nathaniel that mentioned earlier? Yeah, slow in, fast out. You know what? That makes me think for a second. Hang on one second. Let me see if I can find something for you guys while we're killing time here. I used to have, it's ironic that they're calling the next generation of the cars an Evo, because I used to have one. But I have to see if I can find the picture of it for you real quick. I have no idea where I've got them.
You a madman for this, yo. Straight facts, it's shifty. Everything is litty, litty, litty. Riding through the city, city, city. All I really want is love and laughter. All the other drama doesn't matter. Everything is litty, litty, litty. Riding through the city, city, city. All I really want is love and laughter.
Having trouble finding a picture. But the deep learns. Yes. Dim deep learns. Let's see. Albums. I think I've got an Evo album somewhere on Facebook here. There we go. Oh, this is from the racetrack from a few years before. Let's see if I can find the right picture. Does that come up? There we go. There's my Evo. My baby. I miss her. There was a lot more done to the car. That's from like 2013, but it had all kinds of aero done to it and all kinds of good stuff. So yeah, that was my baby, man. 2008 GSR 5-speed, built engine, 2.2 liter turboed, big turbo. She was about 500 wheel horsepower, and it was very loud, and I could rip down Ventura Boulevard in LA and set off all the car alarms that were parallel parked. It was a fun game that I like to play. But yeah, that's at Virginia International Raceway. We were racing up there. Did Streets of Willow, Willow Springs, Button Willow, all the courses in SoCal as well. So yeah, she saw some time. But ended up selling her about 18 months ago. Found a guy that it was mostly had turned into a garage queen. I wasn't really driving or doing that much with it anymore. I was traveling so much and doing other things. So found a guy that was a professional photographer, wanted an Instagram car, basically. And he bought the whole package for basically what I was asking for it. So that's my baby. But she's in a good home now. Actually, I don't know if I could find him again, but I've got him on Instagram somewhere. Now I'm curious. Now I want to go look while we're sitting here waiting, killing some time. Mars, you had asked about Minecraft. Let's talk about that as well. So here's the scoop, guys.
As a courtesy to our speakers, please silence.
Turn this down. So the idea is we wanted to prove out a way that we could take a running thick application, installed application, running in a VM in the cloud, and swap that over to a container-based workload, keeping the data the same, and try to do it non-disruptively or with at least a very quick cutover where people could log right back in and continue working. We were looking for that magic app that we could do that with as a fun experiment. And somebody in the chat a few weeks ago mentioned, well, how about a Minecraft server? And it was just great idea. Absolutely loved it. How much boost did we use on it? I think it was 29 tapering to 26 is what we had it. So it's about 30 pounds. And then as the power would fall off, it would taper down to 26 psi. But it was a what did they call it? It was a Map Performance EF3 Turbo. It wasn't the biggest one, but it was this one right under it. I wanted the whole power band. I didn't just want all top-end power. But that thing pulled like a freight train. It felt like a 1,000-horsepower car, and I've driven a 1,000-horsepower Supra, but that thing pulled like a 1,000-horsepower Supra. It's about half the weight of a Supra. But back to the Minecraft server, it was what we're trying to... Basically, I bought the $25 server license for Minecraft, which gave me a jar file, and I go and I run the Java server, but it's constantly complaining about latency, and it's constantly complaining about not having enough memory and all kinds of things like that. So that's what we're working on. That's what we're going to work on tomorrow for the first little bit. See if I'm getting error messages when I try to do the XMS and XMX commands to set the memory for the JRE. And I'm having all kinds of issues there. So hopefully I can find a Java person. I'd love to find somebody that knows Minecraft server operations really well and that can come in as an admin and help me set all the security up so that we don't have somebody take over the server and do some heinous shit once we really start building stuff. So that's what we're going to work on tomorrow, noon Eastern. Make sure you got the little notifications turned on so you can get a little chime there. But I'll have some of the video content stuff, some of the highlights to put up on YouTube, hopefully in the next week or two. Holidays are here. This 6-week run of trade shows has really put me behind on making some YouTube videos and things like that. So we'll get more of that done very, very soon. Yeah, the bot doesn't let you put links in there in case somebody comes in and starts putting like porn links and stuff like that. It's just something it blocks. Keeps those pesky EMC guys from coming in and harassing me. with a Supra meme. Give me the search string and I'll go find it real quick. All right, hang on one second. Is it the first one that's 18 seconds, or is it the second one that... Oh, there's a whole bunch of these. There's like 3 of them that came up. It looks like it's a garage. All right. Hang on. All right, let's have some fun here for a second.
Dude, is this a Supra? Is that a Supra? Dude, is it a Supra? Dude, is this a freaking Supra?
That's funny. I'd never seen that one before. Oh, we're starting, it looks like. That's funny. A video feed of Dr. Vogel's getting hyped backstage? Yeah. Hats off to the events folks at reInvent, by the way. That stage is absolutely beautiful. And you've got different things going. You've got a stage, you've got a DJ stand, you've got the racing thing off to the right. And also,
Are some people in your dressing room, they claim to be from your agency?
ask and you shall receive, Nathaniel.
Hey, what's up, man? How are you doing?
Nice to meet you. Such a pleasure.
So my name's Channing. I'm the creative director for Craftwork Agency. Can I call you Verbs?
No.
Cool. Okay. Right on. Oh, let's just dive right into it, okay? So we synced up with our research division, and we discovered something really interesting. Every time you wear a new t-shirt, AWS likability ratings skyrocket up 3% to the cloud.
Really?
Our strategy team has identified a unique opportunity where we can leverage your new t-shirt at the keynote. And if we help you find the right t-shirt, we think that AWS likability can scale up to like 5 to 6% year over year.
Maybe 8 to 9% of our Twitter game is slick.
Can't I pick my own t-shirt?
Oh no. Verna, that is like so last year.
So last year.
Yeah.
Okay, show me what you have.
Okay, so nihilism is like huge on TikTok right now.
No.
We don't even know what this means, but it's like super buzzy.
I think our customers are smarter than that.
Yo.
No.
Right? I mean, come on. Like adorbs, right?
I don't think so. No, that would be insulting to our customers.
Yeah, that's what I'm told.
That's pretty cool. I'd
Last
wear
one.
that.
Better.
Now check this out. Wham.
Of course.
Yeah?
Well, I wear that face all the time. I would look good on someone else. Why don't you let me pick my own t-shirt? So thank you for all your help.
So he's probably... That's a yes, right?
No,
Cool. Okay, right on.
Please welcome
yeah.
Chief Technology Officer of Amazon.com, Dr. Werner Vogels.
Here we go, gang. Settle in. We got a good 2-hour ride ahead of us. Enjoy. Thanks for following. Thanks for joining us today, guys. Enjoy Dr. Werner.
Nice t-shirt, Shifty. Look at that. Welcome, everyone, to the first day event. I hope you had all a really good reInvent until now.
Osdorp
As
posse?
always, it's a learning, it's an educational
I
experience.
honestly don't know what that is.
And I hope that you guys learned a lot in the past days. I thought I'll do something different this year and really focus on a bit more behind the scenes of AWS and Amazon than on sort of new features and services. So the one thing that we've been very fortunate at AWS is that we've been doing this for, 13 years now. And we've gotten a lot of experience in that. And that experience has allowed us to innovate in ways behind the covers that maybe if you've
compression
seen all the
algorithm for
new
experience.
services and features that have been launched in the past days, that you sort of forget that there's a lot of things that we're doing behind the scenes. And there's a quote from Jeff Bezos. He says that sometimes innovation, if you want to focus on innovation, you have to focus on the things that will never change for your customers. Because if you do that, you create flywheels that will benefit them forever. And it's easy to see how that works in retail. Yeah? A larger catalog means that you have a higher likelihood that you can find what you're looking for, lower pricing, better guarantees on delivery. But then how does that work for AWS? What are the things that never change for our customers? Security, performance, scale, reliability, cost efficiency, operational excellence. All those things never change. And anything we do over those parameters will benefit you forever. And most of those things are not things where we put out a press release about. It's really things, sort of innovation that we do behind the covers to, for example, always make sure that we improve the performance of all the components in the system that we have. And so I thought that today we look at some of those things that we've done at AWS behind the scenes and do a little bit of a deep dive on them and see what kind of lessons we learned from those. And then maybe you'd like those lessons as well, and maybe you can take them home and do something with that. So the first thing where I would like to talk about is virtualization. Virtualization has been sort of the bread and butter of the compute parts of any cloud environment from day one. And it's one of those major technical underpinnings that have really allowed cloud computing to become as big as that it is. And if you look at classical virtualization,
are we going to get some micro VM news here?
In the 60s, the major mainframes had already run virtualization. But the way we see virtualization today, basically the x86 virtualization, this really came to life by major research at Stanford and at Cambridge. The one at Stanford resulted in VMware, and they made use of sort of binary rewriting to trap the privileged instructions into the hypervisor. Xen took a different approach, and Xen actually modified the operating system to make sure that it trapped into the hypervisor to execute these privileged instructions. So if you look at sort of what is the basis of virtualization, we really pushed the boundaries of virtualization over time. There was something in virtualization called the root I/O virtualization tax. That's basically, if you have all these guest OSs, they are all fighting for the same I/O resources. And especially you see that in the network. If you looked at sort of when this virtualization really scaled up, you would see that most of the customers, or most of the guest OSs, would see significant jitter and variations in latency on their network, mostly because they were all fighting for the same network device. So with that, we started to think about how can we radically change this and think about sort of rethinking virtualization such that we can actually create a base for innovation for our customers. It also had to do with the fact that the newer kind of architectures really were being hampered by the old style virtualization. Basically, we really wanted to give our customers performance at almost bare metal if that would be possible. And we saw that with traditional virtualization, there was significant overhead in all of that. So we really wanted to build a modular system. At least that's the things we do at Amazon. We're really thinking about sort of taking some of the lessons that we've learned in software and actually apply them to the hardware world and the virtualization world as well. Basically, you should see the traditional virtualization world as the monolith. Where all the hardware components.
We're talking about virtualization as the traditional monolith now. How scary is that?
And so what if we actually take the lessons from microservices, where you have small building blocks, where you can really quickly innovate on, And if we can apply those to the hardware world as well, maybe we can change the world of virtualization as well. So just think about sort of, can we create a world where we have all these devices and they have an API? The API may be a hardware API like your PCI bus, but it's still a it's still an API to virtual hardware. So let's take a look at sort of all the different steps that we've taken in sort of the evolution of the Nitro system. Then we started off with really traditional virtualization. And really thinking the first problem we tried to solve was that of the network. Because basically, just transferring, let's say, an 8 gigabit file from S3 would result in literally hundreds of thousands of kernel traps.
It's always
so
the
we really
network.
wanted to see whether we could actually solve that particular problem. So what we did, we actually moved the network component onto a separate card.
Oh?
And so that was really the first version, and that was actually what you saw in the C3 instance that we launched in 2013. And we really learned a lot from actually offloading the I/O onto a separate card. And it took us actually another 2 years to really become much more familiar with what it would take to actually offload processing onto separate cards that sit on the same server. Step 2 was actually in the C4 architecture when we started working with Annapurna Labs to actually move EBS processing into a separate card. So no longer is the sort of the volume processing and the network there happening on the main CPU.
So is their back end doing NVMe over Fabric?
That was such a success of the Nitro cards in the C4 that Annapurna Labs actually joined AWS, and we started working on the C5, which was a major jump because we could also do all I/O that we were doing on the servers. We would offload all the I/O onto separate cards. And the next step was then to really start thinking about, can we actually remove all the other pieces of the hypervisor and move all of those into a control plane on separate card? And that became the complete Nitro system. So there's a Nitro controller that does the management. And then we also built a new hypervisor that is absolutely really minimized. And so you can do all of this. And so the first ones were the X1s, and they actually really became much more faster, much better performance, and much more secure than we could ever have done before.
I've never had it broken down.
So let's take a look at sort of how this works, how you interact with it. And basically, if you would create a volume, an EBS volume, you would do a volume attach. That would actually talk to the EBS control plane, who talks to the EBS card on the Nitro in the Nitro
explain
system,
why they're making their own processors.
who then actually makes that as an NVMe device, notifies
Think of how many
the
of those
PCI
they're
bus,
buying and manufacturing.
and then
how much
the
cost they're saving.
hypervisor traps that and actually mounts that volume then in the guest OS. And we've been quite successful with this. If you look at sort of the pre-Nitro hypervisor, and this is sort of a typical jitter that you would be seeing if you interact with an EBS device. This is after we offloaded it onto Nitro. Basically, all jitter has disappeared. This had allowed us to double the IOPS to EBS, increase the throughput tremendously, and if you heard it earlier in the re:Invent, that the EBS optimized bandwidth has actually increased from 40 gigabits a second to 19 gigabits a second. Now, this is networking and EBS, which is really important for actually all of our customers. But if you look at processing, what has happened to the processors? And if David Brown earlier in the week talked about a customer who had a requirement of 150 microseconds processing time. And if you look at the C4, which is before the Nitro hypervisor was introduced, you can see that the customers had trouble actually meeting the processing capabilities. Then we asked the customer to actually try the same thing on a C5. And as you can see, the C5 has performance that is almost close to bare metal. This is purely because the hypervisor is so thin that it is no longer in the way of the guest OS to get the performance that they want. The same goes for storage latency. Yeah? The i3s were already beasts in sort of storage, but you can see that after the introduction of Nitro, both at the P50 as well as at the end of the performance spectrum, there's rock-solid performance. And it's increased almost as much as 4x.
Yeah, I worry about Vogels every year.
The same is if you look at the network-optimized instances that we've created. Yeah, the ones with the N at the back of the instance name. And if you went to Peter DeSantis' talk on Monday night, you saw the additional board that they've created to give you a 100 gig network. And again, performance increased 4x. And it's not just that we were looking for improving performance. With actually offloading all of this onto separate cards, we also could improve security. Yeah? Trust no one, kill DOM0. Yeah? We have to remember that DOM0 in the old style virtualization is a complete Linux instance. Basically, you could log into it and do a memory dump. That is a very big security risk. Yeah? And as such, by actually removing DOM0, you also remove any SSH or other access to the devices. And as such, you create a much more secure environment. Oh, thank you. This different, and actually this is a very important part of the whole Nitro security design. Basically, you have to control the communication flow. What can happen is that the Nitro controller will talk to the hypervisor. That's allowed communication. The hypervisor is not allowed to communicate back. If the hypervisor takes actions to control, to actually access the Nitro controller, you know that the system is compromised and you can isolate it and you can start investigating it. The same goes the external control planes, whether that is EC2 or EBS, they are allowed to communicate with the Nitro controller, like we just saw earlier on in the EBS example. The Nitro controller, however, is not allowed to take any other actions. If the Nitro controller actually starts actively going out on the network, you again know that the system is compromised and you can isolate it. This is a unique communication design that allows us to build extremely secure systems. Yeah, so you really need to be able to do, in my eyes, trusted computing in an untrusted world. And as such, we've created two trusted parts. Yeah, there's the Nitro system, but the Nitro system also sits on a complete trusted network by itself, so that all the components can actually talk to each other. Another thing that we were able to do is actually add
I agree, Nathaniel. It felt like Ballmer was back up on stage.
You know
going,
developers.
Developers.
Fan of actually, so encrypt everything. And with Nitro, we are able to encrypt everything. We encrypt your communication out of the Nitro cards by default. Everything is encrypted by default in Nitro. Yeah, and not just the things that go out over the network. Also, your local disks are encrypted by default with no performance implications at all. And as you can see, in that way, we've actually improved security significantly. And we can't even trust the hosts or the guests. Yeah? We have to make sure that the guest can no longer, at no moment, actually do anything to the hardware of the machine that we do not allow them to do. And one thing, for example, that we absolutely do not allow them to do is to modify any of the non-volatile memory in the machine. And what we also do when the machine boots up, to actually cryptographically check all the components of the machine to ensure that they are never compromised in any sense, and otherwise we will isolate the machine and actually start investigating. The cool thing was that Nitro now became a base for innovation. Now we could do all these other things that we could never do before. For example, we could do live updates. We could start patching the operating system. We could start patching the hypervisor from the Nitro card without anything taking down. We could add new hypervisors to it. We could also start running bare metal. And we could also create outposts. All of these things have been enabled by the fact that we've created this platform called Nitro that controls our computer environments. There's also another innovation that we had been asked. Can we actually protect?
Don't forget about what AMD did with Ryzen,
data?
where they separated
We have
the
a
memory
number of
controller
customers,
as well.
and of course, EC2
Watch out
is
for
used
AMD.
for a lot of highly sensitive processing. The customer has asked us, can you do something more for us? Yeah, are there any innovations that you can do? And given that we're now at Nitro, we could do very unique things. And earlier this week, we announced Nitro Enclaves, which allows you to cordon off a little piece of the memory, and that memory is called an enclave. And in that enclave, you can run your code, and the code is continuously checked to be cryptographically correct, making sure that that code is never compromised. The enclave also has no access to network or to disk. And you, as the parent instance, you can actually communicate it over vSOCs with a secure channel. This allowed quite a few of our customers to have even higher control over sensitive data. Now, if you look at sort of Nitro-related innovation, can you figure out where that started? Yeah, we've been able to increase the release of 4x number of instances after that we introduced Nitro. And it really has been a game changer. It has really changed the way that we think about our compute environment and the control over our compute environment. It also allowed us to go up the stack and think about sort of, can we find support for, not just for VMs, but can we find support for containers and for serverless? And with that, we introduced a micro VM called Firecracker. And here to tell us more about Firecracker and Fargate is Claire Ligori, Principal Software Engineer at the AWS Container Team. Claire.
I kind of hate to see Firecracker getting forked off as much as it is, instead of everybody coming together and making one project great. That's the one thing that scares me about it.
Hi, I'm Claire Ligori, and I'm so excited to be here today to take you under the hood on Fargate. Fargate is serverless compute for your containers. On Fargate, we run tens of millions of containers for our customers every week, and security is our #1 priority for those serverless container workloads. Virtualization provides a strong isolation boundary between workloads, and in Fargate, we use virtualization to isolate customers from each other, and even to isolate each copy of an application. An application in Fargate is made up of one or more containers, and each copy of that application runs in its own virtual machine under the hood on Fargate, isolating it from all other containers running in Fargate. Inside that virtual machine is a dedicated kernel, network interface, data volume, and credentials, so we ensure application isolation at multiple levels. I'd like to show you an example of what a typical application looks like running under the hood, running in these isolated virtual machines. This is reInvent Trivia, an online trivia game about reInvent, and it's running on Fargate. On Tuesday, we announced that you can now use Fargate with the Elastic Kubernetes Service, EKS, and I'm running this application using EKS and Fargate. So I'm going to show you what happens under the hood on Fargate when a large traffic spike comes into this website. Say, for example, I showed it in a reInvent keynote to thousands of people. So let's first look at what happens when I run this application with EKS without Fargate, running on my own EC2 instances. To handle changes in traffic, I've configured Kubernetes to auto-scale both the number of containers, called pods in Kubernetes, and the number of EC2 instances. So with normal traffic, like we're seeing here, I'm running a few pods on a few EC2 instances. Now, I've just shown the game in the keynote, so of course the traffic is going to flood in with people trying out the game. But it takes a little while for Kubernetes to spin up enough EC2 instances to run all the pods needed to handle that traffic. So while we're waiting for those instances to start up, we're under-provisioned, causing that big latency spike. Then after a while, the traffic is going to start to drop off. Kubernetes is going to spin down pods and eventually terminate those EC2 instances. But that instance scale down tends to lag behind the pod scale down. So during this time, we're actually over-provisioned. Let's now look at what happens in the same situation, but running under the hood on Fargate. With Fargate, I don't have to worry about having enough EC2 instances to run all of these pods. It's serverless compute. Fargate takes care of isolating each pod in a virtual machine and allocating the right amount of compute per pod.
That makes my head explode. Serverless
So now
compute.
that traffic spike comes in again, new pods are spinning up, and Fargate is quickly allocating a new virtual machine per pod under the hood. There's a small latency spike there as pods start starting up, but it's quickly resolved once they're up and running. So using Fargate, the number of pods can react really quickly to changes in traffic to the site. Kubernetes spins down these pods as traffic is dropping off, and I don't have to worry about being over-provisioned because I'm using Fargate serverless compute.
Is it EC2 VMs?
Side by side here, we
missing
can
something?
really see the difference between running on my own EC2 instances and running on Fargate. With EC2, we saw both under and over provisioning, but with Fargate, I was able to quickly react to changes in traffic. Fargate isolated
Do they
each
just
of my
have
pods
thousands
with a
of
virtual
worker
machine,
nodes sitting
and it
there waiting for
allocated
their
the
number
right
to get
amount of
called?
compute per
That-
pod. So
Is
now
that
that
the
we've
secret
seen
to
how
Fargate?
Fargate scales out and isolates the containers for the serverless compute, let's now look at the virtualization technology we use to provide that strong isolation boundary between applications. Since Fargate's launch, we've used EC2 instances to isolate applications and virtual machines. In this model, each application is allocated a fresh EC2 instance running the Fargate data plane. But traditional virtual machines are
maybe.
pretty heavyweight
More
to
aggressive
use
PID
for
loop,
isolating
yeah.
containers. Traditional virtual machines tend to present a lot of
So,
interfaces
shut down
and
hard
devices
now.
that containers simply don't
Kill.
care about.
Terminate instance.
As a small example, a traditional VM will typically present a video card and reserve at least 4 megabytes of memory for graphics. But containers almost never have a graphical environment, and they can be really small as 256 megabytes on Fargate. So these are wasted resources when using traditional VMs to isolate containers. Fargate provides better efficiency for isolating containers.
Now we're
Fargate
talking.
is purpose-built for isolating containers and functions in virtual machines called micro VMs.
There's our answer.
Micro VMs provide the same level of isolation as a traditional VM, but they're fast and lightweight. They don't have any of the devices they don't need. The device
Using
model
Firecracker.
only implements the devices that are actually needed by containers and functions. So there is no video card inside of a micro VM reserving 4 megabytes of memory like in a traditional VM. In fact, a micro VM requires less than 5 megabytes of overhead total. So it's highly efficient to use for isolating containers. And we've been really excited to see open source projects like Weaveworks Ignite and Kata Containers leveraging Firecracker to provide fast, efficient isolation in their projects. So with Firecracker-based isolation, each Fargate application can be allocated a fresh Firecracker micro VM instead of a fresh EC2 instance.
Oh, Nathaniel, have you not
These
seen the demo
micro
from
VMs
last
look
year?
pretty similar to the
Of
EC2
Firecracker?
instance I showed you already. They look the same on the inside. There's no difference to the application container running inside them.
Oh, we might have to watch that.
And they have
after
all
this.
the same components like the Fargate data plane. But with Firecracker, we're able to achieve better efficiency compared to traditional VMs. We can pack many micro VMs onto a single Nitro bare metal instance, with each micro VM running its own isolated Fargate application. As we run more and more of Fargate on Firecracker, that high density means better efficiency in Fargate. I want to share a bit about what we're working on now.
We'll watch
under
it
the
after
hood
the
on
keynote,
Fargate.
Nathaniel, because
We're
I want to remind
optimizing
everybody
how
about
we
it, because I think
fit
it gets
Firecracker
lost
into Fargate.
in the craziness.
We originally ran the same Fargate data plane inside each micro VM, just like we did on each EC2 instance. But that's no longer optimal at our high scale and high density on Nitro bare metal.
Basically, imagine if you could run
So
a
we've
virtual machine that
redesigned
was
the
about
Fargate
150
data plane
megabytes in
from
size.
the ground up for the
And you can
unique
spin up
needs
10,000
of
of them
serverless
at once.
container compute.
That's
This
Firecracker.
new data plane that's under development now is designed to run directly on the Nitro bare metal instance, where it manages all of the micro VMs and their container workloads inside them. The containers running inside the micro VMs can actually start up faster in this model because they don't have to wait for any other
You can
components
see there at
to
the
start
bottom
up
of the
in
image it
micro
says
VM,
Firecracker.
like that
It's got
Fargate
its own
data plane.
runtime as well for specialized for this
We're
environment.
developing a core component of this new Fargate data plane in the open on
There they go.
GitHub, the Firecracker Containerd project. Firecracker Containerd makes it simpler to use Firecracker to isolate containers. It enables using the open source project Containerd to manage Firecracker micro VMs. It minimizes the overhead required for isolating containers in micro VMs. And it exposes container images as block devices to the micro VM. So check out Firecracker Containerd on GitHub for a little sneak peek at the future of part of Fargate under the hood. Thank you so much.
Yeah, Sean or any of the other NKS guys that are watching, I would love to see us take advantage of Firecracker for bare metal casework.
So,
That's cool stuff.
we are, of course, fortunate that the micro VMs also allow us to run Lambda. Yeah, and I think if you looked at
really?
the watch.
The Tri-Lambs, Revenge of the Nerds, anyone?
If you've seen Lambda improve over the past years, what we've done in the past was it weeks, months, and we released some really cool stuff. I think, given that many of you rely on VPC boundaries, we're able to actually really reduce the startup latency within VPC boundaries. And if you look at sort of the new concurrency scaling that we've released, and all the other components with proficient concurrency, you can get really good control over your startup times, and quite a few other pieces. The thing is that with Lambda, as well as with Fargate, we always thought that the serverless technologies will be first adopted by, let's say, young technology companies. And it turns out that's not the case. The rapid adoption of serverless is happening in the enterprise. Mostly because you really only have to pay for your execution times. And the management is so much simpler. And as such, enterprises are adopting serverless at tremendous speed. And I'd like to introduce to you Jeffrey Dowse, the IT executive of Vanguard, to share about how they are making use of these technologies to completely revamp Vanguard. Jeffrey.
Come on, come on. Yeah, yeah, yeah.
Good morning. I'm thrilled to represent Vanguard today, and I'm excited to share with you Vanguard's journey to the cloud. At Vanguard, our core purpose is to take a stand for all investors, to treat them fairly, and to give them the best chance of investment success. Let me introduce you to our firm. We're a global asset manager. We have 30 million investors. They entrust us with $5.7 trillion of their assets. We offer 450 investment products. We have 17,000 crew. That's how we refer to our employees. We have no physical branches. We're a digital firm. 90% of our client interactions come through digital channels. We have 40 years of lowering the cost to invest. Most importantly, we have industry-best client satisfaction results. From an IT perspective, we're big and we're complicated. We have global data centers, mainframes, thousands of servers, lots of storage, thousands of apps, 50,000 endpoints, 5,000 technical staff, and in our business, downtime is not tolerable.
Well, nobody anymore.
6 years ago, Vanguard's senior IT leaders set out on a transformation. We knew that if Vanguard was going to stay competitive in the digital age, we needed to be better at the business of IT. We wanted to accelerate the pace of innovation.
Downtime hasn't been
We wanted
tolerated
to
since
deliver
like
business
2011.
value at startup speed.
If not
Continuous
sooner.
delivery, DevOps, microservices, cloud, new ways of working, CI/CD, all of these concepts were in play. But we knew cloud was the cornerstone to going fast. We knew it was the linchpin to our success. So we set out on a private cloud journey since we had some concerns about public cloud security.
Yeah, I think these guys were big in OpenStack too.
1 year into our journey, back in 2015, we sent 3 of our cloud architects to reInvent. Upon their return, we knew we could not compete with the cloud-based services being delivered by AWS. We also knew that building a private cloud was going to take too long and be too expensive. A quick huddle with our CISO and other senior leaders, we pivoted to public cloud, and we selected AWS as our cloud provider. With public cloud as our destination, we quickly formed a cloud construction team, many of whom are in the audience today. Thanks, guys. They are full stack in their structure. They are outcome-oriented in their mission. Most importantly, they have aligned goals. So how does a big firm like Vanguard, with big data centers, get to the cloud? What was our starting point? We had a traditional tech stack, heavily virtualized. We had big data platforms, monolithic applications. I'm not talking about monoliths that are 1 million lines of code. We had monoliths that were 30, 40, 50 million lines of code.
Damn.
And we had an APAS running on-prem for our emerging portfolio of microservices. Following a design guideline of security first, commensurate with a heavily regulated asset manager, we built out our accounts, VPCs, and a security apparatus that entailed over 150 security controls. With security in place, we wanted to start moving some of our workloads to the cloud. We started with some of our web apps, our microservices. We moved our APAS. We thought this was the fastest way to start getting some workloads into the cloud. At the same time, we established secure internet connectivity using Route 53 for DNS, AWS's Web Application Firewall, and CloudFront for CDN. We also migrated from VPN access to Direct Connect for improved resiliency and bandwidth between our facilities. Then we wanted to shut down our rapidly growing on-prem big data platforms. We became heavy users of S3 and EMR. Other machine learning capabilities such as Comprehend, Lex, SageMaker, Transcribe, and Glue were introduced. More AWS security services were implemented. We used secret managers for authentication credentials. We used Macie for discovering and protecting sensitive information. And we used Shield for DDoS protection. We knew we had to get our data closer to the microservices. They were still reaching back to our on-prem data center for their data.
I think we're getting there, Nathaniel.
Using CDC technology along with Aurora, it allowed us to move our data in a similar schema from our on-prem relational databases.
You know what they never do is reveal the cost difference
Some
between
of our
running the two
microservices
different
solution
ones.
delivery teams wanted access to
this
data
is impressive.
in
This
more
is
of
years
a
of work.
key value structure, so we introduced Dynamo. Using Kinesis for data streaming and Lambda for event-driven data transformation,
Jesus.
we began moving to DynamoDB. And this put us in a position to eliminate our cloud-based data cache.
Wow. All right.
Our next huge design decision focused on our APAS. We pivoted to ECS on Fargate. As mentioned earlier in Werner's remarks, we got stronger container isolation, we got security out of the box, We got integration with other key services, especially identity and access management. Most importantly to me, the guy that was paying the AWS bill, we got into a pure consumption model. And we hooked ECS on Fargate up to Dynamo and Aurora. We are now starting to drain our microservices from our APAS. We are accelerating the pace of our monolith decomposition. And this should allow us to retire our APAS in the near future.
Wow.
Finally, we started to move the gold copy of bounded context of function and data to the cloud. Recently, we have strategically decided to host our emerging advisory platform on ECS on Fargate. This platform supports our advice services that are increasingly in demand from our clients.
It's a hell of a story for Fargate. They just replaced an entire data center with Fargate.
So here's our
and
end
Aurora.
state, just about a 100% cloud-native architecture.
Damn.
So what does Vanguard get out of this? We know we can reduce the cost of compute by at least 30%. We know we can build software 30% faster. We know we can deploy our capabilities 20 times faster. And all this leads to a better ability to innovate. And along the way, we get improved resiliency. Since 1973, Vanguard has been disrupting how investors pursue financial security. Today marks the 17th time Vanguard has been on stage somewhere at reInvent. I'd like to thank AWS for these opportunities. I'd like to thank the Vanguard Cloud Construction team for making all this possible. And I'd like to thank our investors who entrust us with their assets so that they can enjoy financial security. Thank you.
I love a good architecture breakdown. It just it turns my gears. That was pretty. That was really nice. I wonder how long it took them to do all of that. Probably, I'm going to guess 5 years.
It's really cool to hear from customers
guess.
for like Vanguard, especially seeing all the benefits they're getting out of the platform.
Yeah, that's a hell of a customer success story.
One thing, if I think back about when you just talked about
you're passing that one out to everybody you go to.
I think about sort of a more general concept. And it's the fact that at AWS, and Amazon as well, but AWS especially, we always think about evolvable architectures.
Ugh.
And what do I mean by that is that
the amoeba behind
often when you start
freaks me
building
out
an architecture, you have to be keeping in mind that that might not be the same software you will be running a year or 2 years from now. And especially when you have to scale up, like we often have to do within AWS, you have to make sure that, for example, with each order of magnitude, you can almost revisit the architecture that you have built. And I think probably there's no better example for that than S3, the first real service that we delivered to everyone. And I remember that when we were designing S3, we had a number of objects on the board that we thought we would be storing in the first 6 months. And just for the heck of it, we added 2 orders of magnitude to it. We blew through that in the first month.
Wow.
Yeah, and that certainly meant that we had to keep a good eye on our architecture. Now, last year, Milan was on stage to talk about sort of how S3 evolved over time. Yeah, and it started off with 8 microservices. And last year, when Milan was on stage, there were 153 microservices in S3. Wow. Now there are 262. Wow. Yeah? But for example, all the new capabilities that you've heard about, for example, S3 Access Point, which was launched in Andy's keynote, that's a new microservice. S3 Replication Time Control is 8 microservices. The Access Analyzer for S3 is another 4 to 5 microservices. What this shows is that we're able to evolve the system because we've taken really good care in thinking about that this would be an evolvable architecture. Now, one of the things that I'm always proud of with S3, and it's one of the core principles in S3, is reliability. Mostly because, as I always like to say, everything fails all the time. And mostly, if you think about hardware, if you think about disks, they really have high failure rates. But network controllers do weird things. You have bit flips in memory. There's all these things that will happen to you at scale that you need to be able to be prepared for. And that's even the hardware. Not even thinking about sort of like black swan events, like a bug gets hit in one of the components. So we're always thinking about how can we reduce the impact if things fail. How can we reduce the impact on our customers?
Wait, microservices is a monolith now?
So we're always thinking about how to reduce the blast radius. And I've talked last year, and last year also Peter Voschel gave a great talk on cell-based architectures. Yeah, and so let me just quickly revisit that. Yeah, if you would have a regional architecture, something that spans multiple AZs, a cell-based version of that would sort of bring smaller components into that, such that the blast radius of a potential failure is just limited to the cell itself. But also if you have a zonal architecture, something that just lives in one zone at a time or at different zones, you can also actually make use of cell-based architectures for the same approach. It is always the case that we want to reduce the blast radius. How exactly to pick the size of the cells? If you have smaller cells, then you can really reduce the blast radius. It's easy to test and easy to operate. But if you have larger cells, they're more cost efficient and reduce splits. Yeah? And so you can also see the whole system is easier to operate. And the question is always how to really nicely partition your system such that you can actually make use of cell-based architectures. Now, if you think about a zonal-based service in AWS,
if you can keep the blast radius small enough, the changes would be easier to approve.
Let's take a look at the kind of things that we've done in EBS
Subjective.
to really reduce the blast radius in that world.
You could have one giant file that's more important than 10,000
EBS as a block store
smaller
service,
files.
but don't think about it as something that has just disks attached. It is really the case that there are multiple shards that actually make up the volume. And of course, we replicate that. Yeah, so there is another set of shards that actually is the replication for all of this. Now, to control any type of failures of any of these shards, we have a configuration master. Yeah, and the configuration master sits actually on a second network. The second network is a sort of an overflow network. It's not as big provisioned as the front-end network between EC2 and EBS. But the configuration master sits there. The configuration
just give me an
master
example,
does nothing.
Nathaniel. You're
Actually,
an Oracle
the
guy,
only
if I
thing
remember
it
right.
does is when
You and I have
any of
been
these shards would
twittering
fail,
for a long
when any
time.
of the nodes would fail,
It's like
it
DBS
sort of
versus redo
restarts,
logs.
triggers
Neither
the
of them are less
re-replication.
important than the other.
So it's actually
but
pretty
the sizes
simple.
can be vastly
Yeah,
different.
so something fails, it fails it over to the backup, and then starts re-replicating to a new set of shards. And so the configuration master doesn't have to do that terribly much. But if multiple things fail at the same time, this thing can get easily overloaded. And especially because we're not talking about one disk, or we're not talking about one volume, we are talking about millions and millions and millions of volumes. And so if you only have one configuration master, that configuration master actually becomes a single point of failure.
Yep.
Because it can easily get overwhelmed. So thinking about sort of what can we do to improve that. Now, as always,
Have a config master in each zone.
there is always this tension between consistency and availability. The CAP theorem says that in a world where you have partitions, you cannot have and consistency and availability. But consistency in EBS is non-negotiable. So we need to make sure that we have an environment where we can actually ensure both high availability and consistency, and make sure that the consistency never gets traded off. Again, cell-based architectures come back into this. Yeah? So if I apply that to EBS, an EBS master, what you would do is you can maybe start off with one in a zone, and then you split the zone into two, and maybe you split them into four. And every time you reduce the blast radius of impact of a failure or an overload of the configuration master.
Also, it's per cell instead of
But
per
we're
zone.
thinking about this.
Got
We're
it.
thinking about what is actually the smallest unit of cell that we can actually achieve with EBS. And then, especially for the configuration master, then it dawned on us that actually the EBS is a very unique case, and the configuration master there as well, because not all data needs to be available for all clients. Yeah, remember that in essence, in the old-style database
but who's the
world,
arbiter of that?
That meant that you have this one database that needs to be accessible by all your clients. That's not the case here, because it's only the client, only the EC2 instance and the EBS volumes that actually need to have access to this particular configuration data. So instead of splitting it up into 4, we went to millions of tiny databases to ensure that the blast radius in EBS is as small as possible. Yeah, and Visilia comes out of from a lesson in the world. It's the Portuguese man of whirl, and it looks like a jellyfish, but in essence, it just consists out of hundreds or thousands of really small microorganisms that have a colony together and present this one thing to you. So that's where the name comes from. If you look at what the data model is in
That's clever.
Each volume that gets created gets a partition key. And each database in Visilia manages only one partition key. And then what you do, you create this colony of microcells, where each of these cells support only one partition key. And so that really means we end up with millions and millions of these cells, but that's okay. They're small and simple to manage. And the cell lives in the same environment as the nodes. And so actually inside the cell,
the ML model?
There's 7 nodes.
Is it?
Runs Paxos, and actually is able to have a distinguished proposer as the master. So run 7 cells with Paxos to have the state machine be reliable. One of the things that we've been able to do with Visilia as well is to make sure that these cells are always as close to the client as possible, because these databases are really tiny. And so what often happens is that clients move throughout the AZ. Yeah, volumes get attached to different servers, things like that. So with Visilia, we're able to make sure that the configuration master lives as close to the cells as possible, to the clients as possible, and as such, again, reducing the blast radius. So if you look at what the impact has been at Visilia, this is before Visilia. This is the error rate it's an aggregated error rate of accessing configuration master in a pre-Visilia world. And you always, as you can see, what happens after that is actually pretty spectacular.
Wow.
So again, cell-based architectures play a very important role here, and in this particular case,
it was
we've been able to go
0.06% at the
to
peak. It's not that
cells
drastic.
that are as small as one single key, and as just significantly reducing the blast radius of any potential impact of a failure. Now, if you think about
that's what they say, 3 nines availability on an AZ, right?
There's some other techniques that we've learned over time at Amazon that I think is very cool. Because especially if your application is either stateless or has soft state, what are the kind of things that you can do? Yeah, and so this is where clients actually are involved in the story as well. Think about a regional architecture. And I just used a deck of cards as representing the different customers at the dice, given that we're here in Vegas. If the diamond one actually starts introducing enormous workloads, or he pushes something so hard that a bug is being triggered. If you have a regional architecture, it might take out the first node, and what it will do, of course, it will immediately retry. And with that, it will take out everything in your whole region. Now, if you have a cell-based architecture, basically you map your customers onto a particular cell. Now, so if again the same scenario happens, what happens is that the 2 nodes in the cell get taken out. Okay, good. In this particular case, only 25% of your customers are affected. This would take the clubs. No, what is that? Yeah, it's clubs. And so, but what now if we go to something completely different? And it's called shuffle sharding. Basically, what you do, you have a number of nodes, and you have you actually take each client twice, and actually do a random hash, or just randomly spread them over the different shards. If now Diamond is actually introducing failures, what you can see is that they're actually not another customer that shares the same cell is affected. Which means basically that if you look at the math behind this, it's basically combinatorial. Because in this particular case, with 8 nodes and a shard size of 2, the failure rate of the impact of a particular failure is only 3.6% of your customers. Now, that's if you have a very small set. But imagine if you improve this to 100 and have a shard size of 5. Then you can see that any one client can almost not impact any of the other clients. And so as n grows, the combinations grow, and you can really make use of the math to actually really build a highly reliable system and really minimize the blast radius of any failure into the system.
Servers, queues, and other resources.
It doesn't mean that you have to have a smart client that actually knows how to do retries.
That's pretty awesome.
And things like that. But for the rest, I think the math really builds this well. Now, with all of this, building distributed systems
Somebody
is hard.
get Werner a towel, please.
Yeah. And we've always done that. And we've done this at Amazon for the past 20, 25 years at scale that is unparalleled. And so what many of you have always been asking us, how do you guys do this? Yeah. I mean, after 25 years, you must have a lot of experience in building these kind of systems. So how does Amazon do this sort of build resilience into that? How does Amazon engineer at this scale? What are the kind of lessons that you have learned about managing operations? And so we've been thinking about what we can do there for you. And we've gotten our best engineers and architects together who have been given talks over the past years. And I'm happy to announce today the Amazon Builders Library that will actually bring all of this information for you so that you can build highly reliable systems, just like Amazon is doing. And so we're launching this with 15 articles, and in all sorts of different areas. And for example, how to implement
I used to
health
read
checks.
Netflix's
What
tech
are the best
blog
practices around that?
for stuff like this.
What is the history of Amazon there? What are the kind of things that we've learned there? And so I hope that this all helps you build distributed systems at the same scale and the same reliability as that Amazon.
Time to fire up the
AWS
PDF
is
scraper,
doing.
yeah.
And so if I think about that we're all charting into uncharted territories. Yeah, and then our next customer is one that is really charting new territories. So Saildrone is a very exciting startup that creates wind and solar-powered autonomous surface vehicles, and they're making use of all sorts of technologies to chart everything in the seas. So I'd like to invite the CEO of Saildrone, Sebastian de Halle, to actually come and talk to you about that. Sebastian.
Our oceans are unbelievably vast, covering 70% of the planet. They act as a powerful engine driving complex planetary systems that affect all of humanity. And yet, ocean data is scarce by any standards. And that's because oceans are not just incredibly vast, they are also unforgiving, dangerous environments. Now, on land, we have grown accustomed to billions of connected sensors, but at sea, we only have hundreds. principally for moorings. Imagine a large steel buoy tethered to the ocean floor with a 4-mile-long cable weighted down by a set of train wheels, which is both dangerous to deploy and expensive to maintain. Now, of course, satellites have been providing the big picture over the past 25 years, but they can only measure a few variables.
That's a good
with
picture.
low resolution, and they cannot see through water. So we know we can do better. After all, we've been using robots to study distant worlds in our solar system for a while. So it's about time we start quantifying our own planet, because we cannot fix what we cannot measure.
Well, look at it this way, Nathaniel.
We cannot prepare
You've now got a
for what we
roadmap to
don't
start a
know.
consultancy.
So this is what we set out to do at SailDrone.
If you
Our
wanted to break
breakthrough
out on your
started
own,
10
they
years
gave you
ago,
the manual.
Pursuing the
Here's
land
how to build
sailing speed
Amazon
record.
or
On
AWS.
March 26, 2009, our founder Richard Jenkins broke the record in the Mojave Desert. 126.2 miles per hour in a wind-powered car called the Greenberg Mark V.
Wow.
That record is still standing. And thank you. And this was the birth of the SailDrone. At the core of the record was an innovative wing and tail arrangement, similar to what provides lift to an airplane, but tilted 90 degrees. This is a solution that's capable of producing immense forward propulsion for very long periods of time, but it only consumes less than 3 watts of electrical power, less than a refrigerator light bulb. And each SailDrone carries a suite of sensors to measure atmospheric and oceanographic variables with incredible precision. Things like wind speed and direction,
I look at this and I smile
air
because I go,
temperature,
data
pressure, barometric
storage.
pressure, humidity, solar radiation, but also in the water, water temperature, salinity.
Of course, they're probably
dissolved
putting in an
oxygen,
S3 or something,
dissolved
which we'll
carbon
find out here in a
dioxide,
minute.
atmospheric carbon dioxide, underwater sound, current profile, biomass, bathymetry down to 1,000 meters. I'm talking about a powerhouse of data collection. And of course, not just one SailDrone, but a global fleet of SailDrone. And this incredible planetary infrastructure, naturally, is powered by AWS. SailDrone is all about endurance and resiliency. Our robots are working around the clock, achieving mission duration of 12 months or more. So Werner's talk about resiliency is the exact reason we chose AWS as a cloud provider, a partner that can not only massively scale, but that can also provide industrial strength resiliency. And AWS delivered, enabling us to provide mission-critical data, real-time, around the clock to a global customer base without skipping a beat. Here's an example of why this resiliency is so critical. Better fish stock data is very important to manage our fisheries. This is information that affects millions of jobs globally. And after millennia of growing catches, 1996 was peak fisheries. Catches have been flat, indicating severe overfishing of our oceans. But how do you manage a resource that you cannot measure? So the mission is estimate the biomass of various fish stock, such as pollock, sardines, mackerel. And SailDrone do this using sonars, a device that emits sounds, a sound wave, and listens for the echo from the back of fish and from the seabed. And by painting the ocean with sound, you can develop large statistical model of biomass over very, very significant areas. So we do this with fleets of SailDrones, because the fish migrate, so the faster you count them, the better the estimate. So here's a fleet of SailDrone at work over the Bering and Chukchi Sea in the US Arctic, which is home to about 1/3 of our commercial catches. And closer to home, we do this work every year along the west coast of the United States, from Vancouver Island in Canada all the way down to the Mexican border. This is truly groundbreaking work by autonomous vehicle. Above the surface, our onboard cameras are busy accruing a very large data set of tagged images, which we have come to think as the ImageNet of the ocean. And this data set now powers the very first machine learning algorithm optimized for maritime domain awareness, which is a place where everything is always moving in every frame, a very complex problem. This is, of course, still work in progress because the ocean keeps on surprising us, and the algorithm encounters novel scenes like a drone riding seal, which is very hard to tag.
That's funny.
Earlier this year, SailDrone successfully completed the first ever unmanned autonomous circumnavigation of Antarctica. You've seen from the Deep Racer how hard it is to go around the track. We went around Antarctica 196 days, non-stop, from New Zealand to New Zealand. And data from this mission quantified the key role, thank you, that Southern Ocean plays in regulating our planet's carbon dioxide, a key driver of climate change. So to achieve this feat, we relied on some serious data crunching on AWS to navigate from waypoint to waypoint. First, we had to ingest numerical models describing changes in pressure systems, which in turn drive various wind patterns from different directions, something that influences the trajectory of the drones in pretty dramatic ways. Below the surface, we had to track currents, which are eddying around and swirling, can slow our progress, and of course, waves. 60-foot large waves, different wave height, different periods, which act as so many obstacles that can slow our progress or literally destroy the vehicles. So as you can see, as we zoom in onto the drone, you can see that the navigation logic is actually quite complex, navigating these multiple fields in the most optimal manner. And this is a task we accomplished seamlessly with clusters of AWS compute, and then sending the resulting instructions to the vehicles via satellite. Our longer-term vision is one we called the quantified planet. It's not about just one sail drone. We're dividing the entire global ocean into 1,000 subdomains, each 6 by 6 degree in size. And we're working to deploy a drone in each of those boxes. The goal is to achieve planetary coverage and thereby help deliver better insights into those planetary systems that affect humanity. And we can do this because these systems, like weather, can now be modeled numerically on AWS using new instance types like P3 and C5N instead of the old supercomputers. So combining the AWS compute and Saildrone's unprecedented in-situ data, we can deliver new insights into global precipitation, for example, or into global wind, monitoring hurricanes, storms, and typhoons. And of course, for long-term monitoring of heat fluxes in the tropical Pacific, the famous El Nino. And we do this delivery in all in near real time. We compute, package, and deliver these insights in the hands of our users globally via our Saildrone Forecast app.
And we sell it to the government, and we sell it to the Weather Service, and all of that.
Our next frontier is mapping the global seabed.
How are you affording all of those P3
instances? As hard as it may be to believe, 85% of the global seabed remains unmapped and unexplored. And we are hard at work to solve this data collection problem. But big problems need big solutions. So we have built the ultimate machine for this task. And I'm very proud to present the Saildrone Surveyor, which is a 72-foot-long wind-powered vehicle carrying a 1-ton sonar system capable of imaging the bottom of the sea down to 8,000 meters. That's 24,000 feet.
Wow.
So together with our partners, we aim to complete this mission within the next 10 years, creating the very first complete map of Earth for the benefit of humanity. It's a true planetary endeavor, and it involves unprecedented scope and data set. And like so much of our work, it's really made possible by our collaboration with AWS to help store and process this amazing set of critical data. So we're excited to see what the future holds as we explore new realms and new possibilities with Saildrone, and we look forward to continuing strengthening the amazing partnership we have with AWS. Thank you.
Anything that helps with climate change and mapping the bottom of the ocean, which is still a bigger frontier to me than the universe.
Weather predictions, fluid dynamics.
I'm all in.
If you want to see how you can treat AWS as a supercomputer, you should rewatch Peter DeSantis' presentation from Monday night, where he really explains how you can make use of EC2 instances to build supercomputers. Now I want to take a little bit of a different track now, looking a bit at more at the big industry kind of stuff that we've seen happening, especially in the world of manufacturing. And so Industry 1.0 was, of course, at the end of the 1800s when steam machines came into action, and we saw the whole industrial revolution started to take place, and gin carts starting to be invented. And so if you now look at sort of from Industry 1.0, moving over to 2.0 is where electricity gets introduced. It becomes this big source of power. And you start to see major shifts in the manufacturing process as well. Because the first assembly lines are being built. in those days.
Eric Staples,
Thank
thank you
3.0
very much
is
for
when
the
all
follow.
the
Welcome to the
electronics
channel.
start to arrive, and all factory floors start to be sort of controlled through PCLs and things like that. And then in the next phase, in what we now these days call Industry 4.0, is where automation starts taking place. Yeah, where everything becomes automated. And especially also things like logistics and everything else around. But are we really at Industry 4.0? Because I don't really believe that so much. Yeah, because if you look in 2015, the average age of the equipment in factories is 22 years. And they have never been so old as since 1935. Yeah, and factory equipment really is too old to be able to produce the data that we want to get out of this to create insights. And so I don't think we are at 4.0 yet, because
I don't either.
factories and manufacturing sites need to change significantly if we really want to start creating insights into this world.
Oh yeah, he got a break while the
and if you look at all the different pieces
sail drone guy was up there.
Still really a big deal in manufacturing sites, there is no data that is helping them create that insight. Yeah, and the data needs to start flowing out of these manufacturing sites into places where you can actually do the analytics. And if you want to create insights, there's a lot of insights to be had. Yeah, and if I look, for example, at predictive maintenance, or autonomous transportation, wearables, collaborative robots, all of these kind of things is, in my eyes, what Industry 4.0 is about, but there is hardly any manufacturing that is already at that pace. And today, factories are already producing about 1,800 petabytes of data a year, but it's only a small fraction of what is needed to really create the insights into this world. And whether that is in manufacturers, or whether it is in smart cities, or if you actually start moving this data into the cloud, you can actually have multi-layers approach. And whether you want to do things that this is actually where we are, here, yeah, or if you want to go out and actually start thinking about transportation and how companies can make smarter decisions about computation. Yeah. Or, for example, move out into the level of cities, or go even further. Yeah. Go up and think about sort of what are the kind of things that we can and have to do around agriculture. Now, the world actually grows more and more. The expectation is that by 2050, we have 35% more people in this world that need to be fed.
Yeah.
All the way to transportation. Yeah, we can have all these multiple layers of how sort of we should be collecting data and how this data need to grow together to create new insights. And sort of, if I think about that, and I think about sort of bring that back to how Amazon operates, I think back on sort of the physical parts of Amazon.com, and that's the fulfillment centers. Yeah, so in the early days, we sold books. Yeah, and there were about 3 million books when available when Amazon started. And of course, fulfillment was challenging, but they had their own logistical challenges, but it's actually relatively simple. However, if you need to start selling TVs and toothpaste and pillows and shoes and coffee, things become a lot more complex. Yeah? And our plans was really to do that. So in the early days, it looked like a lot like a normal warehouse would look like. But that definitely is no longer the case. Yeah? We aimed to really sort of create better deliveries. Yeah? We moved at one moment from $25 free shipping, and then to 2-day shipping, and 1-day shipping now. And if you're with Prime now, you get it within an hour. So how do all of these things change while you still need to improve worker safety and make sure that you can do the guarantees at the speed that you would like to do? Of course, in all of that, in a typical warehouse, there's about 4 million bins and about 10 million items. We use computer vision throughout the systems. We set it out in what's called the Manhattan grid style, where the paths are, which the pods, the Kiva systems can actually follow. They bring them towards where the workers are, so that you can put things in a box together and make sure that actually if there are two items that you've ordered, that they do go into the same box together. And as such, we use machine learning to actually predict how to do these things. Yeah, and it's definitely in 4 different areas.
Talking about changing the world, but not in a touchy-feely way, but with data.
What products should we be buying? And then there is, who should we buy it from? Is this from a large manufacturer? Is it from a mom-and-pop shop? And then the question is, where do we place them? And then if we want to place them, what kind of promises can we give to our customers in terms of delivery? And this is actually pretty challenging. Yeah, because actually if it's a very popular product, like something seasonal, like warm socks or sun hats in the summer, that's easy to do. Or if it's just coffee and things like that. Those are all easy things to predict because they actually sold across the world. But what now if you need to, if you have a Nicolas Cage reversible sequin pillow cover?
Genius.
Well, if you have that one, that's harder to predict where you would actually have to place that one. And so, but what you can do, you can make use of machine learning and look at thousands and thousands of similar items and start making predictions where you should buy them. So that if you are in Vegas and you want this pillow, you probably can get it in the coming 2 days. And that's where machine learning plays an increasingly important role. And if you look at many of the things that we've done at Amazon in the past 20, 25 years, machine learning is probably at the basis of all of that. And it is that small stuff like vendor lead detection or fraud detection, or all of these kind of things that are all happening behind the covers, but also major innovations like Alexa, yeah, or the drones or Scout. All of these are driven by machine learning. Or probably the most extreme one that you all know about is the Amazon Go store. You could just walk in.
That's not the most extreme one that I know about.
Take things off the shelf, put it in your bag, and walk out and you get charged. There's enough challenges with all of that. Yeah, you have to first figure out what the account is and how the account is moving through the store. And here you see an anonymized CD representation of that. And some of these you see turning yellow. And that means that we're actually not really certain what the account is that is actually moving that. And all the challenges are with computer vision is actually with products. You know, some products are the same, but they crumbled. Yeah? Or other products are actually really almost identical, but they're different products. And then also, how are people actually interacting with the store? And so we've invested a lot in generating synthetic information such that we can actually start making these algorithms more efficient and more accurate. And it all results in, you can just scan in when you walk into the store and walk out and get charged. And all of this is, of course, powered by AWS. But if you look at sort of outside of AWS, outside of Amazon, there's so many cool things happening in the physical world that are actually powered by AWS. So let's take a look at a few of those. Yeah, first of all, about sort of workplace safety. This is one of my favorite examples of customers that went on a path to improve the quality of their operations and the safety. This is Woodside. They are a liquid natural gas producer in Australia and have actually a significant operation. One of the parts of that producing liquid natural LPG, whatever, is actually to freeze it down to 160 degrees under zero. And so that happens in this massive refrigerator over here. And one of the things there, in the old world, if you would have sensors on them, the only thing that these sensors would do is alarm you if something went wrong. They didn't have any ability to produce data. Woodside moved to a system where they actually were producing data, and actually, so there's a process part of this, is a failure part that's called foaming. And that would sort of an alarm go off, and then the whole factory would have to shut down for maybe even weeks, and it's a pretty hazardous environment. And so what happens now that these sensors, and there's 10,000 sensors in this refrigerator, if actually they now can actually start to predict foaming and no longer create these hazardous conditions for their customers. But so after that, this is the first experiment which they did. And after that, they flipped the switch and brought 200,000 sensors online.
Wow.
And actually started to create autonomous environments for their workers. All these environments are extremely hazardous. And so on one hand, they have autonomous platforms that are out in the sea, and there's no workers on there. There's only robots.
Yeah.
And in this
basically
case,
all refineries along the Gulf Coast.
The robots that are actually moving throughout their plant, which is an extremely hazardous plant, without any danger to the workers. Because the workers sit in a centralized environment.
I have a good story about this. I'll tell you guys a little bit. I used to be.
Are also seeing.
I pretended to be a chemical engineer
one time.
That you see
popping up are IoT sensors, and they run AWS IoT Core there, and they're able to actually take actions if sort of control things need to happen, instead of just having to send people in big hazardous suits out there to do the work for them. Module is another interesting company. They make wearable devices to improve workplace safety, like safety belts and gloves and things like that, so that they can track how workers move through hazardous environments. And there's one interesting story that they told me, is that one of the major US airlines actually use these safety belts to measure how far people are actually bending over, how far their workers are bending over, and whether they actually use the right techniques to pick things up from the ground to really improve worker health. United Rentals is moving to create these massive machineries that are completely autonomous, so that nobody longer needs to work with these massive machineries in hazardous environments. Another area that is really interesting for in this digital sort of physical world combination is the way that cities are being made smarter. And there's a lot of work going on in that particular world.
Shout out to Boston. They're doing a ton of work for this whole smart city initiative
examples.
In Boston.
ShotSpotter measures gun activity in a city. And apparently for every gun-related homicide, there are 100 gunshot accidents that are never reported. They make use of multiple sensors to really be able to accurately and within 60 seconds be able to actually identify where the location was of a gunshot and send and have law enforcement actually take over that. The city of Miami has taken this on, and in
I don't know how
2014,
I feel about that.
And since then, homicides have dropped 35% in Miami.
Less homicides is obviously
Virginia
better.
Beach has put sensors out
treading
in
on
the
some
ocean
dangerous territory,
to start
though.
measuring and predicting when floods are going to happen. The same is for Myovision. They actually put sensors in and around the streets so they can optimize transportation. Another very interesting sort of physical, digital world is that of agriculture. And there's a lot of work going on in the world in finding new ways to feed the future. And there's two of our interesting customers in that space. One is the Climate Corporation. They actually make use of the whole digital architecture. It's called Climate Field View. That make use of all the sensoring of their tractors and other equipment on site, as well as satellite imagery, to help farmers optimize yield. The Farmers Business Network is an interesting one, because here is farmers that are sharing anonymously information about the yields of their fields and the kind of crops that they are growing, such that they can actually have collective bargaining with seed providers, as well as setting the prices for the crops that they are selling. And the same goes for the world of transportation. And whether it is Siemens that are putting sensors all around the world on train tracks, because the biggest cause of delay is often bending of the rails and things like that, so they can all measure that.
Thank you. I hope that's how you pronounce
Deutsche
that.
Bahn,
Thank you very much for the
big,
follow. Welcome to the
German
channel.
transportation provider is putting this out in also in sensors in each of their trains, so they can accurately measure delays and things like that. Vantage Power is an interesting customer because they have sensors in all the electric buses, so they can do preventive maintenance on the batteries of these buses. And then if you think about sort of coming back to where we talked about earlier, is really modernization of manufacturing. This is all about creating data streams out of manufacturing to actually really optimize insights. And to talk more about this, we have a really interesting next speaker. He has won the CIO Innovation Award of CIO Magazine this year. And to talk more about this modernization of manufacturing is the Group CIO of Volkswagen, Dr. Martin Hoffmann.
Hi, I'm Martin Hoffmann from Volkswagen. Volkswagen started with the Beetle. Today, we are a group of 12 iconic automotive brands. And the brands with our portfolio are VW, Audi, Porsche, Bentley, Bugatti, Lamborghini, Seat, Skoda, Ducati motorcycles, MAN, and Scania trucks.
Jesus.
We have 365 models in our portfolio. So if you want to drive a different model every day, it's going to take you a year of pure fun and joy, I promise. We produce 11 million vehicles per year, which is about 44,000 a day. Why do I mention this number? This is a massive scale.
Wow.
And a
That's a lot of
requirement
cars.
for any supply chain on a
That's a
global
lot of
basis
damn cars.
to run in a very efficient and effective way. So our supply chain is highly complex and global. We have more than 1,500 suppliers globally, and they produce and manufacture every day more than 200 million components and parts. And these components and parts have to be shipped into our global factories. So there are 18,000 trucks per day shipping components into our factory, 7,700 ships on the oceans, crossing the oceans with produced vehicles. And in a year, it's about 75 million cubic meters of material that we process. And we do this in 122 factories worldwide.
Wow.
5 in North America, 9 in Brazil and Argentina, 71 in Europe, 4 in South Africa, 33
71
in China,
factories in
and
Europe?
India. All these factories are running on different grown technology. They have a different age, and so it's very hard to scale from an IT standpoint. So what we are doing together with AWS, we're lifting 122 factories into the cloud. And we do this with one common global architecture that we are building with AWS. So this entire project is what we call the Volkswagen Industrial Cloud. Right now, probably the biggest IoT project in the manufacturing world. And we chose AWS not only because of technology, but because of the ability to scale, to provide us with standards for our factories. The implementation speed that we are getting from AWS methodologies, the flexibility, and the culture is helping us to really accelerate this project. The way we build it, in the center, we built on AWS Cloud what we call the Digital Production Platform. This is an AWS Cloud platform in which we connect all the machines, the robots, press shop, print shop, the body shop, assembly machines, the logistics system, they all get connected into the cloud, on which we run heavy lifting AI and machine learning algorithms, IoT services, and security controls to constantly optimize and compute situation of the factory. And then what we do is, on top of the AWS cloud, we put what we call the Volkswagen Group App Store. This is where we develop use case-based applications for the factory. We develop it once and copy-paste in all our factories. They can download it from the cloud. Applications like predictive maintenance, algorithms that manage and optimize factory functions. So this is our digital production platform. Now, if you take it and extend it to the outside world, which means we are integrating, connecting all our suppliers into that cloud. We're integrating all logistics companies, equipment manufacturers, and all our business partners will be connected to the industrial cloud. We're even that open that we will open it up for other automotive manufacturers to use applications and technology in the industrial cloud. They're also invited to contribute.
Did he say they're open sourcing it?
And to load software into the cloud, like an open source ecosystem. So this is going to be one of the biggest ecosystems that will be built in the industry.
That's huge.
The architecture behind, I can't go into all the details, and you know them better than I do, but there are 4 major building blocks that we're using in the architecture. One is the OT, Operation Technology IT Gateway, connecting machines, robots into the cloud. It's the edge gateway, because a lot of the functions and workloads have to run close to the machines. We're using outposts, 2 outposts per factory, because there are several applications that have to run on-prem, and this is why we're using outposts for our plant cloud. And the 4th element is our DPP Enterprise Cloud. This is the application framework, highly standardized, where we'll be able to quickly, at higher speed, develop applications for our production system and keep them in the cloud. Now let me show you something. This is where it all happens. This is the shop floor. This is where the AWS cloud gets married with our machines, with robots, with welding systems, and all you can imagine running a factory. So thousands of sensors are constantly sending data into the AWS cloud, into our digital production platform, so that algorithms, machine learning algorithms, can constantly optimize the setting of the factories and parameters of the machines. And we will also run applications for our employees based on the cloud to better manage our factory system. As Werner mentioned earlier in his talk, transformation in manufacturing goes way beyond automation. It's about full integration of all data points in the factory.
It would have been really funny if he had licensed the Terminator theme song and played it over the top of that video. That would have been
Volkswagen
awesome.
Industrial Cloud is the foundation for our new production strategy. In the future, we will have autonomous factories, darkroom factories, and this is the start in that direction. But we will also reduce factory costs by doing that. We define IT standards between the plants.
We also eliminated
We increase
thousands of jobs.
Production program fulfillment. That means delivering vehicles on time to our customers.
And
our
replace them
product
with
launches
full-stack
will be much
engineers.
faster so we can come to market earlier with new vehicles. In numbers, it's a 30% increase in productivity. We can decrease our factory cost by 30%, and we are targeting 1 billion euros of savings in our supply chain. It has been an incredible journey with AWS as a partner. Thank you very much.
So if they deliver on that, because I know Ford and GM are doing some really cool work as well. If they deliver on that and they kind of standardize the automotive industry on a single platform on AWS.
So I've been fortunate in the past years to travel the world and meet with many of our customers. And it's always interesting to see that there's a certain group of customers, younger businesses, that are trying to solve really hard human problems. And whether that is around education, whether it is around health, all of them are working hard in tackling the hardest human problems that we have at this moment. For example, Aquabite is a company out of Bergen, is in Bergen in Norway, and they're working on how to create protein. Yeah, the protein is likely to become the major food source in the future. And so what they do, they grow salmons. And a pen like that easily has 200,000 salmons. And so it's interesting to see that they allowed us to come on site and actually video this. So we started a TV series called Now Go Build. And there's been 8 episodes by now. And
we'll have to watch those here on the stream.
With some of the world's hardest problems, where young businesses are really tackling hard problems in collaboration with AWS. So this is around food. This is one of my favorites. This was the first episode we did. It is a company called Hara Token in Jakarta. And the problem in Indonesia is that many of the farmers, the small farm holders, have no identity. And as such, they cannot get loans to buy seeds for their farms. They have to go to a loan shark, who there in Indonesia often charge 60%. And so by giving these farmers an identity, but not only an identity, also measure the size of their plot of land and the yield of that plot of land, they're able to give these farmers an identity and data that they can take to the banks. And the banks are eager to actually give these farmers loans because the repay rate is almost 100%.
Yeah.
So again, these are companies that are really tackling really hard human problems. There was one episode that was a bit more fun in all of this, and that's the episode we released today, the episode that we did in Amsterdam.
Amsterdam. I love this city. My city. I'm in Amsterdam for one of my favorite gatherings, the Amsterdam Dance Event. It is exciting to see the role that technology is playing in removing the obstacles between the song in the musician's head and the wall of sound that helps us do one thing: dance.
So the other episode that we've released last week was in Rio de Janeiro, where it's all about healthcare. How to find
That's on the list. We're going to watch
new
those.
ways of providing
keep up with
healthcare
those.
to the poorest
I love
people
stories like that.
in Brazil. Even though Brazil has a national health service,
And it's Werner,
they're
so
not capable of
it's gonna be a good
keeping
time.
up with the needs of the Brazilians, and especially not the poor Brazilians.
I've kind of always
so
said he
I
needed
urge
his
you
own
to come
TV
check
show.
it out.
Well, I guess
These
he's
are
got
very
it now.
inspirational stories of very young businesses on that running on AWS, solving some of the world's hardest problems. Well, with all of that, I hope to see you guys tonight. So have fun at the party and go build. See you.
Now go build. Well said, Werner, well said.
This concludes the AWS reInvent
all right,
Keynote program.
All right. Please join us later tonight at 8 p.m. We will. No, we won't be doing that. Okay, all right. We'll get him out of there. Turn some of our music back on. All right. And we'll do a little bit of that right there. And yeah, there we go. Well, there we go, guys. Oh, I promised you something. Hang on. Don't run off just yet. We've got to watch one more thing. Just one more thing, right? Let me find this real quick, make sure I get it pulled up. Let me switch things back to this. And then I'll pull, let's get rid of this guy. All right, we can get rid of him. And we'll pull this up because I wanted to show you the craziest thing that I had seen. This is the blimp. This is the blimp warehouse that Amazon, I think in 2016 or 17, filed a patent for and won it. So if you think things are crazy now with what you can get, they're only going to get crazier. It's not the right scene. Let me pull this up. Sorry, guys. There we go. Things are only going to get crazier. Imagine you're in your city, you're in your apartment, and a drone is coming down from a blimp warehouse in the sky, delivering you your Prime Now package. Imagine a sky full of Amazon, a giant Amazon distributor warehouse that just floats over your city endlessly, runs on solar and wind, and then you have these little, I guess, like trucks that come in from distribution centers to restock the warehouse in the sky that is delivered by drones. This is a very real thing that is coming. There are patents. They have patented this. The other thing I wanted to show you is, let me find, here it is. Let's pull this up, and I'll kill the Spotify, and we can watch Abby and these guys.
Engineer on the Firecracker team here at AWS. And we are here to talk about one of my favorite announcements so far that came out last night at Monday Night Live, formerly
this is from
known
last
as
year,
Tuesday
by the way,
Night Live,
to be clear.
And which I'm now calling Compute Christmas. So Anthony, welcome. Thank you for joining me. Yeah, can you tell us a little bit about the Firecracker launch?
Sure. So Firecracker is a virtual machine monitor. And what that means is that when you're running something like instances in EC2, there's always a hypervisor. That's a bit of software that's running at the lowest level, talking to the hardware, that actually lets you run multiple instances on a single physical machine. So what Firecracker is it's a type of hypervisor, and it's really a type of hypervisor that's oriented towards serverless workloads. So it's for running things like functions and containers and things like that, things that aren't really based on legacy systems. So when we build like a normal hypervisor for running instances, we have to support virtual hardware and things like that going back to the 80s. And it really kind of slows things down, and it's not really as fast as it could be. So with Firecracker, it's all like stuff built for modern workloads. And so yeah, and then the really big part of it is that we announced it as an open source project. So because the container space and the serverless space is so dynamic today, we really felt like the right thing to do was to work with the community to figure out what the right long-term direction for the project is.
Good question, not sure.
So I think kind of what you're getting at, right, is that the problem that we were trying to solve here is
this
that
is
obviously
Abby
we
Fuller,
have other
in case
kinds
you
of
don't know her.
hypervisors. We have a traditional way of doing things, but as
Spends
kind of
most
the
of
way
her day
we
on
do
Twitter, I
apps
think.
evolves towards serverless compute, it's not really quite cutting it anymore.
But we love Abby.
Right,
She's
yeah,
fun.
so I've worked on hypervisors for my
really
entire
sharp.
career. And I've seen containers kind of emerging over time, and there's always been like a bit of a healthy rivalry between container folks and hypervisor folks. And for many years, we've always talked about,
Should we
hey,
get
like,
ready to fight this
yeah. So one day they'd come together and they'd converge into a single technology that had the best of both worlds. And that's really what we're trying to do with Firecracker is bring both of those technologies together and not have to let customers make trade-offs between performance and isolation and all the things like that.
So go ahead.
For some of the folks who are new to maybe AWS and EC2 and these kinds of services, could you explain a little bit about why we do virtualization?
Yeah. So ultimately, what we do is we provide instances to customers, and we provide instances in the shape that customers want. So I can go off and I can get a T3 Micro, which has 1 gigabyte of memory and a single physical core. And for a lot of workloads, that's all you really need. The trouble is you can't actually buy a server like that these days. The smallest server you can buy usually has dozens of cores and hundreds of gigabytes of memory. And so if you have a workload that really just needs a tiny amount of compute, you need some way to subdivide the system into smaller components. And that's really what a hypervisor does, is it takes a large server and makes it into a bunch of tiny servers so that you can have exactly what you need for your application.
And is the goal just always 100% utilization?
Yeah, of course. So utilization is what ultimately drives down costs,
50
and
to
we
60.
always like driving down costs because we can turn around and turn that into price cuts for our customers.
And Firecracker allows us to do more on this side.
Yeah, so as I mentioned, there's always been some animosity between containers and virtualization. Sorry, virtualization's obviously better. No,
Fighting words.
They are indeed. So it really comes down to security. Virtualization provides a really strong security boundary, and because of that, when we launched Lambda, we actually ran Lambda functions in a virtual machine, because security is the most important thing we do at AWS, and so that's always going to be the thing we prioritize the most. But Lambda functions can be really, really small. They can be very transient. Containers, you can specify exactly the amount of memory that you need, and so it isn't very efficient to run those workloads in their own dedicated virtual machines. That's why we built Firecracker, because we could really provide absolutely the right amount of virtualization for the specific workload.
And you mentioned this was a modern tool, so this is built on modern virtualization technologies. So what is different about the idea
I promise the payoff for this is
in
huge.
1990 versus virtualization in 2000 versus now?
Yeah, the thing I am the most excited about with Firecracker is actually the fact that it's written in Rust.
Rust.
So if you're not familiar with Rust, it's a relatively new programming language for doing systems development. So it replaces languages like C. And historically, all virtualization software was written in C or C++. And so Rust was developed by Mozilla, actually, as a replacement for using C in Firefox. And it turns out that web browsers are actually very similar to hypervisors, because web browsers have to contain JavaScript code.
It's a sandbox.
It's sandboxing,
Randall has,
right?
by the way, a weird hatred of JavaScript. So
that's okay, to each his own. So Firecracker is completely written in Rust, which brings really strong guarantees of memory safety. It's a really nice language to work in, and we've been really, really happy with the experience of developing on top of Rust.
And Yamashi12 just asked, why did you guys choose Rust? And I think you've somewhat answered that question.
Yeah. At first, we weren't really sure. It seemed like it would be a good thing, but we have the development team behind Firecracker is a team in Bucharest, Romania. And that team's just done an awesome job. They've moved really fast. There's been very few bugs. Like normally, in any kind of piece of C software, you always have bugs due to memory corruption, all that kind of stuff. We've just had none of that. It's been super smooth. It's been a great experience.
And is writing Rust as a developer, is it, do you get into the same flow that you would with other languages?
Yeah, it's pretty different. So there's always a ramp-up time. So it takes a little bit to get used to some of the new concepts in the language. But then once you're used to it, you just fly. It becomes really natural and really easy to write code.
So I have a question from Twitch, actually, that I'm going to extend a little bit. So MUU9 was asking about benefits for customers from using something like Firecracker. And I think kind of what they're getting at, and I think that we can look at more broadly, is kind of why do I want to use this? So I think other than compute optimization and space optimization, what do I get out of Firecracker?
So Firecracker's a little different from a lot of the technologies that we launch, like a place like here at reInvent, because we're really launching it very early in its life cycle as an open source project.
Yes.
So we are using Firecracker today. If you're running Lambda functions or Fargate, then you are benefiting from Firecracker. But really, we've put this out there today as a raw technology because we want to work with the various communities. So our vision for Firecracker in the long term is that you as a customer will be able to do things like just do a Docker run and use Firecracker and have good, strong isolation between containers, but still have great performance that you'd expect with containers. That's going to take time. That's going to take working with a lot of folks in the community, but that's exactly why we launched it here, is because we want to do all of that and we want to work with those communities to make that happen.
And I think you guys have already seen some pull requests. It is
we have, yeah.
open on GitHub now. Everyone can see the repo already.
Yeah.
And I think what's also cool is that when it went public last night, it already had a code of conduct and contributing guidelines.
Absolutely.
So they are really
There's since been a fork of this project called Rust VMM.
To start kind of putting some.
Think of it like ESX.
Yeah, we tried to make sure that we did all of the right things in terms of making it easy to contribute. There's actually a lot of documentation for how to contribute, how to get involved. Everything's ready on GitHub today, and yeah, we've got a handful of pull requests already. A lot of us, after the announcement, basically just sat all night.
He's going to demo it here in a minute. That's what I'm waiting
watching
on.
GitHub, responding on social media, doing all of those sorts of things. It's been really, really exciting.
I think Abby had a tweet that just exploded. Firecracker, no pun intended, I'm sorry.
Wow.
Were there a lot of those puns during the development?
No, not at all. So I don't know.
Oh, I'm so glad I'm not on the dev team.
So I heard a rumor, and by that I mean I both heard and started my own rumor, that you have a demo.
I do, yes.
I'm ready. I'm ready for demo time.
Are we ready to do the demo?
I'm ready.
Okay.
This is going to blow your minds if you've never seen this before.
We're good.
Okay, so what we're going to show
Some parallels
is running Firecracker on an i3 Metal server.
Not
so
parallels.
this is an instance type that you can
It's a
launch
script.
today, right now in EC2. And so everything that we're going to show here is something that you could just go off and do right now with Firecracker as the open source project. So what we really wanted to show here is how Firecracker enables us to run many, many, many virtual machines. And so typically when you're talking about a hypervisor and you're talking about a lot of virtual machines, you're talking about 40 or 50 or 60, or maybe if you're really good, you're running 100 virtual machines. What we're going to show is running 4,000 virtual machines with Firecracker. And we're going to see what the start time looks like of those machines. So I'm kicking off right now, and what this is going to do is it's going to start running these virtual machines in groups. And we have, we have this cute little ASCII art heat graph. We are systems developers. We are not graphics people, so this is about as good as we get for demos.
There is no judgment from this crowd.
So what you see is that each of the individual squares represents a virtual machine, and the colors are how much network usage that virtual machine is doing. So what you can see is a whole bunch of virtual machines starting up right now and all doing networking activities. You can see like little bars flowing through the screen, and that's because we're pacing the virtual machine startup times. You don't want to start 4,000 virtual machines all at once. That'll just create like a thundering herd. So we pace it out. Maybe you do. And so what we'll see is that once we've launched all of these virtual machines, we'll go and we can see how much time it took, and we can go and see what the overall startup time was. So and we're actually done starting up now. You can see because all of those little snakes have gone away.
So these are just the individual machines running?
Yeah, and they're running a networking benchmark right now too. So they all are trying to drive networking really fast. And this is all on a single server. So if we go back, we see that it took just about a minute to launch all of those virtual machines.
4,000 virtual machines in a
at
minute.
An individual startup time. And this graph, it's a little messy, but it's a heat graph of all of the individual micro VM startups. And you can see that the maximum startup time was actually 219 milliseconds. Milliseconds. So running 4,000 virtual machines, the slowest one of all of that was just a little over 200 milliseconds.
And I'm not supposed to swear on Twitch, but that is so freaking fast.
And then the average was right around 150 milliseconds, with the deviation being pretty tight. So yeah, this is why we're really excited about this technology. This is very different from how hypervisors typically work. And once you can start up a VM sub-second, in hundreds of milliseconds, it really changes what you can do. It makes doing things like function virtualization or really
that was a year ago.
Transient containers to handle like single requests possible.
So this is probably going to reveal a lot of my ignorance, but how does this work with terms like oversubscription with regard to, in some virtualization technologies you oversubscribe like crazy. Is this Firecracker?
Yeah, so this is all doing oversubscription natively by default. So if we wanted to run this many virtual machines and we were going to pre-allocate the memory for it and do all of that work, you would never be this fast. So all of the Firecracker virtual machines only bring in memory when they need to. They all use a minimum footprint on startup time. So you're getting oversubscription by default with Firecracker.
Wow.
Yeah.
Are there any kind of nuances in the memory models or anything like this?
Yeah, so I think another thing I'll call out is that Firecracker as a raw technology allows you to run virtual machines very quickly. But there's a lot of things that you have to do to get an environment that really will work well in production. And so one of the things that we've done as part of the Firecracker project is that one of the bits of documentation is all the things you need to do to configure Linux in such a way that you've got a good, strong, secure environment. There's lots of little gotchas. And I think this is another area that we're super interested in working with the community on, is making sure that this isn't just a technology that's out there, but it's a technology that folks can consume in an easy and reasonable way.
And integrate into a bunch of different things.
Absolutely.
We have a couple questions about those integrations from the Twitch stream.
Yeah, I think we have a couple people have been asking in broad terms. I'm going to just add all the questions together about the relationship with different containers providers, basically. So are you going to be working with Kubernetes or other parts of the containers community? And then I had another question about the relationship to EC2. So I think for people that are just joining us, what the difference is between Firecracker and just EC2 virtual.
Yeah, so we've started engaging the various folks in the container communities. In addition to releasing Firecracker, we also released a Firecracker Containerd plugin, which we've just started.
It's also in the same Git repo.
It's in the same organization, and that is probably going to be the best way long term to integrate with things like Kubernetes. We've just started those conversations with those communities, so we'll see how it plays out over time. But yeah, we're super eager to build the enabling technologies that allow better integration with things like Kubernetes. Another project I'm super excited about is Kata containers.
Yes.
So Kata containers is an effort to make it really easily integrated so that you can just do a Docker run and that runs in a virtual machine. And that's been an effort going on for a couple of years now, and we've been talking to that community for a while. There's been a lot of discussions in that community around what a next generation virtualization technology would look like built for containers. And one of the very first things I did after we announced publicly was send an email out to that group, because I think that's going to be a great opportunity for us to all work together and
so think about doing just a
term.
Docker run like you normally would, but maybe with a flag that tells...
You can run Firecracker today,
and your runtime environment is going to be...
bare metal instances, and so we have
Firecracker-Containerd. Right?
Peter announced that R5 Metal
it's automatically
going to
spin up the VM that it's going to run in. That's what they're doing on Fargate.
Bare metal. But we
you
already
just do a Docker run on your Docker file.
So you don't have to do anything, and you're already getting some of the benefits
VM for
of
you
Firecracker.
and isolates it.
And there was a question from Twitch, so I'm just going to clarify for a second. It's not Firecracker instead of Fargate.
Exactly. Now you understand how one VM per pod. That's how Fargate's running.
So it's not like you don't have to abandon Fargate to use Firecracker. It's a lower level building block below Fargate and Lambda.
And I'm gonna pause real quick just to clarify. They at this time of this video, I believe they were still doing Fargate with EC2 instances, traditional VMs, right? And what they announced today or this week, was it today? Yes, it was when the lady in the purple dress or the pink dress came out, and she said instead of using VMs, now they're using the Firecracker Containerd runtime. Now all that overhead goes away, and it's just bang bang. Pod scaling up and down is just near instant. It's nuts.
So we have another question from the stream from Mew9, which was asking, how big are the micro VMs that you just started to run that iPerf benchmark?
They are 128 megs.
128 megs.
128 megs.
I also said iPerf, but I have no idea if it was actually
It is iPerf,
okay,
yes, it is iPerf. And so if you do the math, 128 megs times 4,000 is actually more memory than there is on the physical system.
Oh, yeah.
But because of the fact that we're doing paging on demand, so we're only bringing memory as we need it, we're still able to run all of those virtual machines without a performance penalty.
So if I built a control plane on my laptop, I could let the rest of the Twitch staff here all start subscribing VMs, running my own little
sure, you could.
Server.
You could also just use EC2 because
that's probably
it's a lot easier. Or Fargate or Lambda.
I think you're working too hard.
I have another question that's probably, again, revealing my ignorance here, but this is a super interesting area. Do you have to think about the underlying processors and architecture? Does the compiler take care of all of that for you? Because I know different processors have virtualization instructions.
In the same vein, someone asked about ARM support earlier.
Yeah.
So.
Yes. We love ARM. I spend most of my time developing on ARM these days. So yeah, ARM is absolutely coming. It's something we announced as part of the project. One of the
think about the IoT
about
and the edge use cases with this, with ARM.
Traditionally be the challenges you face with virtualization, where workloads tend to be very sensitive to processor architecture are really old operating systems. So most of the pain with virtualization these days is supporting operating systems that are 10, 15, even 20 years old on modern hardware. They get very fickle, they get very confused about running on modern hardware.
In the video he showed the roadmap?
One of the really nice things about
Where did you see
Firecracker
that?
is that because we only run container and serverless workloads, we can use a really modern version of Linux.
Was it back in the video a little bit?
Knows exactly what to do on modern hardware and is flexible, and so it makes everything much cleaner and much simpler.
In Rust, do you ever have to do some of the craziness? I remember back in C++, you would have to kind of inline assembly sometimes just to get stuff to work.
No, you shouldn't do that.
Oh man, I gotta learn Rust.
No, it's really nice because it feels like you're programming a much higher level language like Go or Python, but it actually, like in most benchmarks that you see, Rust usually does better than C code because the compiler can just be a lot more aggressive about it. So
that's awesome.
I think it's awesome too because you usually hear C as being kind of the benchmark, that it's like if you want something really fast, you use C, and now Rust testing faster than C.
Absolutely, yeah. I really think this is the perfect project for Rust, for where Rust is in the ecosystem today.
I also just want to let you know that half the things that we've gotten from Twitch are just people basically being like, "This is so cool."
I was watching this on Twitch last year.
Oh, okay.
A whole line.
And I was just like,
there's hoodies too, but
what?
We didn't wear the hoodies.
So if people want to be part of this community, if they want to contribute, if they want to build integrations, where do they go? What do they do?
Yeah. So the very first thing to do is to go to the GitHub project. And so that is firecracker-microvm. And so you can either access that directly via GitHub, or we also have a github.io page that you can go to that's a landing page. There's a contributing.md file, which tells you all the things you need to do to get started. If you've done open source contributions before, nothing's going to surprise you. It's all really straightforward. And there's already a list of issues that are open. So depending on how you want to contribute, there's really easy things like the documentation and testing can always be improved. I challenged somebody on Twitter this morning that AMD support is really easy and they should just send a pull request.
There's also setup instructions, which I can vouch that I tested myself. So there's lots of stuff there if you want to get started and start answering things. We have like maybe 10 seconds left, but before we wrap up, can you just say what you see coming up next, maybe for what you guys want to work on next for the Firecracker project?
So I think the most important thing for us is making Firecracker easily consumable. And so we're really, really interested in working with the various communities like ContainerD, Kata, eventually Kubernetes, and Docker. That's probably the thing that we're most excited about.
That ContainerD work has paid off now because now it's Fargate.
From the lower level perspective,
it's the back end of Fargate.
I'm a lower level kind of guy. There's so much to do in optimizing both Linux and Firecracker. Right now we're at about 150 milliseconds. I think we can get that much, much lower, and I think there's lots of interesting stuff to do there. So I'm really excited about what the opportunities are in the space moving forward.
You heard it here. Even faster, even more optimization.
There you go.
Awesome. Anthony, Randall, thank you so much. That was tons of fun. If you are people keep asking about the t-shirts. If you're physically here.
We won't worry about that. Let's go back to that one. Oh, yeah, I got to change it down here. All right, and kick some music back on for a second while we sign off. But yeah, I want to reach out to Anthony and even Abby, and can I get an update on Firecracker, like that level? Where is it today, a year later? And there may be a session. Let's. The YouTube channel is already full of recorded sessions from the earlier parts of the week from reInvent. So don't be bashful. If you didn't get to attend the show, they're putting all the sessions they're recording up there. I mean, there's 65,000 people at the show this week. There's no way they could go to all the sessions. So I'm planning on watching a lot of this stuff offline. If I find a few key choice ones, I'll watch them here on the stream with you guys. Specifically like a Firecracker update if I can find that. But yeah, tune in tomorrow, guys, because we're shifting gears. reInvent's done. It's finishing up. Tomorrow at noon Eastern, 9 Pacific, we start with the Minecraft server build. So it's up there. We've got an EC2 instance running, but I think I'm going to either have to grow it or expand it. And part of me is thinking, do we use Fargate for what we transition to? Because there is a Docker file for Minecraft out there. There is a container version of Minecraft. And could we scale that? Just as an example application, right? That's the end goal here, is to take a thick application and transition it to a container. And I was leaning towards trying to use either one of the cloud provider services like EKS or AKS or GKE, or maybe even our own NKS, or maybe a combination of all of them eventually. But now after seeing the movement of Fargate over the last couple of days, I'm going, do we just do it in Fargate? Keep everything in AWS? I don't know. We'll talk about all that stuff tomorrow. We'll figure out a plan together, but I need you guys there to help me. I need a little bit of help with AWS. Some of you guys that are more certified and advanced in that. Some of you guys that, and I'm still looking, there was a guy named Mars something that showed up earlier, said he was asking about Minecraft. I need a Minecraft admin, server ops person that knows all the secret commands to lock it down so nobody can tear anything up. And then we're going to have to figure out what to do with the persistent storage under the Java environment that's running. How do we take the storage of that environment when we transition it from the Java side to be a persistent volume in a container? All that stuff we've got to figure out. Meanwhile, we're going to go build some really cool stuff. Once we get it up and running in the Java environment with the right amount of memory and the right amount of bandwidth, we're going to go build some really cool stuff. So there'll be some sessions where if we can get it all up and running tomorrow, I want to spend the rest of the stream building some stuff in Minecraft, and I hope you guys will come join me. Make sure you got the Minecraft client installed on your computer, and we'll play with that, and it'll be up and running 24/7. I think I looked, and it was like $7 last month for me to have it up and running. Whatever. We'll do all that stuff tomorrow on the stream, but yeah, need you guys there to help me out. Come join me, and we'll figure all that stuff out. I'm Nick Howell, the Data Center Dude. Thanks for tuning in. We will see you guys tomorrow. Hope you guys enjoyed AWS reInvent this week. That kind of ends trade show season for 2019. Take care, guys, and we'll see you tomorrow for the Minecraft server build out. Peace.